Hello and welcome back to IT Security Labs, and I'm very excited today that you're joining me tonight on this live stream. We are actually going to be attacking a Linux machine. This is a Linux machine that we have attacked almost like 5 weeks. We have been attacking a lot of Windows, and today I decided let's go for a Linux machine so we can learn some really wonderful skills. And I chose a machine called Mecury. This one you can also find it on VownHub, but also I have a link that you can download from the description here. It's running in VMware. No, it's running in VirtualBox. And then I'm mirroring the traffic that is coming to this machine here to go to Security Onion. So we are actually doing some real-time intrusion detection. So this is the exciting part here. We're going to do the attack. We're going to see how we can actually break into the machine. But the most interesting thing is we're actually going to go and track down our traffic so we can understand what does it look like, what does an attack look like on a real network. And that's the good part about these live streams. So if you're interested in that, please stick around. You're really going to learn a few things here. Our main focus today is going to be on SQL, particular manual SQL injections. So you're going to be injecting things manually. We're going to avoid using SQL Map. We're going to use everything by hand. And I'm going to walk you through the process that you can do if you are faced with a website and you have to do manual SQL injections, which for the most part, if you are going for the OSCP, you all know that SQL Map is banned. You have to do your SQL injection by hand. And I'm going to show you a methodology that's going to really help you if you ever face SQL injection on a website and you have to do it by hand. It's the most confusing thing, but at the same time, it's actually very easy. So without wasting a lot of time here, I'm running a Kali Linux 2019. And as you can see here, I've already created a directory called Mecury. And to begin with, I'm just going to start by doing a simple Nmap here. So Nmap is going to discover running services in all the ports, and I want you to tell me the service version as well. So SV, and then I would like to do on all ports. So you do this. This will go after all 65,000 ports, and this will go to 192.168.38. I believe I'm on 120. Let me just verify that. 230. So if you go for an exam like the OSCP, you probably have the IP addresses. If you're doing a pen test, hopefully this will be part of your scope, or you would have found this IP address using OSCP or any other tools that you have out there. So that's what we'll be doing right now. Just a simple Nmap. And if you have been around here for a while, you know Nmap is going to get caught by our intrusion detection system. It's very loud. It's not the most graceful tool to use. So if we go back here, our Nmap, if we go to alerts, you see that the ET potential scan, this is all Nmap stuff that's generating right now. So Nmap is very loud. So hello everybody, I see BT, Cyber Warrior, JM. It's good to see you, and thank you very much for subscribing. I'm very excited that this content is actually helping some people, so thanks for subscribing. I appreciate that. So if you're ever going to run Nmap, expect a lot of noise. So if you're curious, like, well, what happens? Nmap has a user agent, just like Hydra and other tools that we use out there. They all have user agents that they set when they are ran. So anyone with an intrusion detection system is going to catch you, especially in this message here. Nmap does say, hey, by the way, I'm Nmap here. See me. And of course, Suricata is going to catch it. In this case, we're using Suricata as part of our intrusion detection system. There's also going to be evidence of Nmap from all the Zik logs that are coming from this. But for now, it's just Nmap. So giving it a moment here. Usually I do a ping before I start scanning. So let's make sure that this thing is actually responding. Oh, there we go. It responded. First, we see that we only have 2 ports. This is going to be unlike the OSCP will give you about 10 ports here or 20. But for now, we have 2 ports. That's fine. That's Vown Hub for you. So what we're going to do is we're going to say we have port 22. Like I always do, my methodology says port 22, you leave that one alone. And unless if I have usernames and password, I have to try right away. I look at the version here, which usually tells me the version of the operating system. But for the most part, this is not going to be my way in. I will use that as a last resort to probe. I don't usually probe 22 unless if the version is really old. So I go straight to 8080. And right here, it looks like I have a 404 error right away, which is not really promising. I see that we have a Python in the version number here. But let's go ahead and visit this website here. So let's assume we didn't have that. I was just testing it out. So sure enough, it says, hello, this site is currently in development. Please check back later. This is a perfect candidate for our attack because, well, what's happening with it? Why is it in development? So I would copy the URL. I will run Nicto because Nicto is fun. Nicto -h. Nicto will interrogate that site and try to see if there's any low-hanging fruits that we can find. And while Nicto is running, I'll also run Gobuster. So let's go and run Gobuster for us here. Or Debuster. And here's some of the notes that I've accumulated over time. Which one do I want to use today? I want to go for medium.txt with Gobuster. So I do this because the syntax is just easier. I'm not in the business of struggling with syntax of some tools. If I've used a tool more than 10 times, I don't want to waste my time with the syntax. 230 on 8080. Let's bust some directories here to make sure that we see if we have anything interesting. This time we're using seclist. That's my favorite word list. All right. So while Gobuster is running, I will go back and check Nicto. Nicto is still running as well. Both these tools are generating a ton of traffic for us. So let's look at that traffic from the Kibana's point of view, because that could be also interesting. Let's see if we have more alerts from those two tools that we're running right now. We're brute forcing some directories, so I'm expecting a lot more alerts. And this is the good side. This is what the good guys would see. Like if you're defending your environment, this is what you'll be seeing. So I'll let this one load as well. My security onion is slow today. All right, right away, you see that we now have spikes here. This is an indicator of compromise. All of a sudden, we are seeing spikes that were not there. Usually you have a baseline which will be normal, and if someone is brute forcing, all of a sudden you start having spikes. So let's just select this region here. And here's a bunch of traffic that's going to our destination of 8080 and 192.168.230. So we know we're actually capturing traffic right now. And right away you see that we now have even a bigger spike right here. That's like over 70,000 events, or I mean 65,000 events that are being generated right now between Nicto, Nmap, and also Gobuster. So let's go back to our tool and see what we have found. So Nicto doesn't seem to be finding anything. I'm going to stop Nicto so I don't keep making too much noise. And Gobuster is still going here. Just a bunch of 404. Let's do the obvious. From the advent of the cyber this week, we learned that we can just start testing, right? /admin. The obvious. Or administrator. And here, it looks like someone made a big mistake when they were developing this. They're using Django here, and in the settings, they enabled debug mode. And what debug mode is going to do is debug mode is going to show us errors and also it will disclose some sensitive information. In this case, because there is debug mode and it's set to true, it's saying, hey, by the way, what you are requested doesn't exist. And I'm assuming this will say the same even if we do cat. Anything that we put here is going to give us the same error. So before we look at those, let's look at robots.txt. That's another obvious one. We don't have anything here. This is for indexing purposes. So let's go back to random one, admin. All right, so this error here, I wouldn't move on until I find out what's going on with it. So this is why I thought this machine is very interesting, and it's like the OSCP, because you actually have to think and connect the dots here. So the next name is goes the index, okay. We also have robots, but we also have the last one here, Mecury facts. We visited robots already. We have index, which is the main one. So the only one we haven't visited is this Mecury. All right, so biggest lesson there. If you're going to enable debug mode, especially in Django, the application, you might disclose sensitive information to attackers. In this case, we saw sensitive information from just the debug error that was showing. So we have two things. We can show some facts. I'll open that. Then I also want to see the to-do list. What I'm doing right now is I just want to see, how does this thing work? Is there anything that it does that I can abuse and actually exploit to my advantage? So I'm just interacting with this. I would also save this image and make sure that I have a copy and do a Stakehide or any of the Stego tools to see if there is any sensitive information. For example, in this image, there might be a name of the creator. Now I would have a username. So I would not just move on without saving this message here. So I'll save that in the downloads. Right. Let's go and see that image quick, so I can show you how we can interrogate an image. Before I run any Stakehide or anything like that, I'll just run strings on this image. All right, so I'm not, when I'm looking at strings here, I'm looking for things that kind of make sense. It looks like I just have a bunch of gibberish for this image here. It's not really going to help me much. You can run like OpenStego or another one, I think it's Stakehide. Let me see if that will work. I forgot the syntax for Stakehide now. Let's see. Do I have anywhere where I've used Stakehide before? Oh, it's just a list of the tools that I was using. So I don't have notes for Stakehide, but you can go to any like hacking articles or anything like that that would show you how to use Stakehide to see if we can do that. For now, I'm going to move on because I have two more things to check here. First one, it looks like it's doing something. Fact one, Mecury does not have any moons or rings. So our website is doing something. It's giving us a fact and fact ID of 1. So can we do a fact ID of 2? See, maybe we can start seeing a bunch of facts. Yeah, we can see. Fact ID of 2. Let's do 3. Yeah, so we can, it looks like we are actually getting information from this site here. And looking at the third to do here, add CSS. CSS is what you use to beautify your website, to make your website, nice looking. Then implement authentication using users table. By looking at this reminds me of SQL. Actually, the next one says use models in Django instead of direct SQL call. Okay, so that means that I'm thinking this might be a direct SQL call based on what I'm seeing here. Then, all right, so based on these two here, I know that I have a users table and I'm doing direct SQL calls. Even without this, as an attacker, I should know that there's a chance that I'm interacting with a website directly here. So what I can do is I can do something that is obvious. Let's go back to effect number 1. Let's go back before that. Let's just go back to effect 1 here. If you are ever faced with a SQL... Thanks, Matthew. I like that syntax. I'll try it. So if you're ever faced with a potential SQL injection through a web browser, the default thing that a lot of people would do is they'll run and grab... what is that little tool that people use? SQL map. A lot of people run and grab SQL map, and SQL map will do all the work for you. Unfortunately, SQL map is banned in the OSCP, so you have to know how to interact with SQL directly, by hand, by yourself. And if you have never tested SQL injections by hand, by yourself, I think it's one of those important things that you need to know, because injections are very, very big on the OWASP top 10 vulnerabilities almost every year. So first thing that you need to do is we suspect that this is a SQL injection, and we found out that we can change this to 2 and 3 and 4. Put the obvious. When you do a SQL injection, first thing that you need to do is 1 or, if you do an or, 1 is equals to 1. We're saying, hey, give me fact that is on ID 1, or 1 is equals to 1. So this is just a true statement. If you put anything that is true here, you will be able to see whether or not you can actually do an injection. So this is the same thing. There's no change here. Or 1 is equals to 1 is the same exact thing. I think I covered this a few weeks ago as well. So if we do an enter here, you see, oh, actually it did take the 1 is equals to 1. Now I'm with a lot of confidence. I now know that this thing is really vulnerable to SQL injection by doing 1 is equals to 1. So that's the first thing that we can do. And now by just doing that, we see we now have more facts, and it actually dumped everything that it had in there. So it gave us a fact that is on position 1, and every other fact that's saved within its database. It literally just dumped all the facts to us by putting 1 is equals 1. Because in every column that we were looking at, everything was true. So it dumped everything that was true, meaning it existed. That's the first part of SQL injection by hand. And anyone, I think, who is interested in information security, you need to try at some point, at least to do things by hand before, instead of trusting SQL map. So that was the first one. After this, I found there's a cheat sheet that I usually use when I'm looking at SQL. Let me see if I have it here. This is actually from Pentest Monkey. So if you are not familiar with SQL injections and things like that, here is a cheat sheet that you need. You might want to pin this to your bookmarks or something like that. It will tell you, okay, what is the first thing that we need to do? Or right now that I know that I can do SQL injections, I'll start thinking about this as if, what if I had succeeded in signing into a database? First thing that I'll do is show me all the databases that you have. Then I'll select a database. Then I'll select tables. Then from those tables, I can list contents of the tables. And if those tables include users, I'll dump a bunch of users. That's the sequence. So if you're ever faced with a SQL database, show the database, and you can interact with the information schema, which is really, really good. So coming up with a step-by-step methodology of saying, if I ever see SQL, this is the obvious things that I do, is going to really help you. So here's a cheat sheet because nobody has memory to remember all this stuff. So what is it saying? First, we need to show all the database, list databases. And here is your information. You can select schema name from information schema, yada, yada, yada. You can use this to actually just dump your database. Or you can list columns using this right here. Then, or you can list the tables using these commands here. So please bookmark this. And the commands that I will be showing you, I was able to make them and construct them using this cheat sheet right here. And you can always do the same. So first, let's go and select our database to make sure that we can see what's out there. And here is the command that I did. And I'll explain what it is. So now that we know we can inject, you remove everything here and leave the one that's there. And I did a union or select. You can see it from our cheat sheet. A union or select will go and select whatever you're looking at for here. This no, actually, this one here is for the tables. Let me show you the one for databases first. Just do a union select database for that one. We're saying union select database from that section. Let's see what databases do we have. And usually what happens is it will give you the result of the first whatever that you wanted. Then the second command here is going to be ran. Let's go back to our cheat sheet here. So it's this one here. All right. So now we know we have a database called Mecury. So your methodology says, okay, I need to find the database. Once you find that you only have one database, you don't have a bunch of databases. In this case, the one that we have, that we are interacting with here is called Mecury. Next, we need to say, okay, what tables do we have in there? For us, we actually have, it says users table here, but let's forget that we were told. What if you are not told? How do you find these tables? That's where the next command that I have here is going to show us for the tables. I've done this on a hack the box machine and I kept the same commands, and it turns out they actually work once you verify that it's the same. And it took me a while to actually come to this because I struggled the most with manual SQL injection, especially of this type here. So union O select. Now we want a table name, and you can see the syntax from there. We want it from the information schema tables because sometimes you might not just select from one database. You want to see some tables from the information schema tables where the table is goes to database. So anyway, if there's a database, I want to see the tables that we have in there that are showing, especially from where we're pulling that information. So I'm just changing this section here. So it will still give us this gibberish here and the quote, but we now know we have two tables, one called facts, another one called users. So now that we know for sure that we have a table called users, this is where we can now go and select users. Let's see here. I think it's somewhere in here. If you like the union or select, there's like multiple ways. If you give this to 5 people, they'll come up with different commands sometimes, but there's the same basic syntax that works for all of them. So the next one is, let's select the users, and I'll show you the union select command for that as well. So let's break this one down. Union or select, so now you get that idea. We want to combine these tables here, these columns here. Select column name from information schema columns where table name is equals to users, just like what we did with the tables. Now that we know we have users, this should list the users that we have. And if you had other tables that you wanted, you can just keep changing this part here. But it's the union or select part that we are doing that should give us the information. Okay, so the users table here, it has a few fields. We have the user ID, the user password, and the user name. Why would we want to see this information right now? Because you don't know whether this column here is called password or PWD, or if it's username or it's the ID part. But now that we know we have two columns that we want to interact with the password, we hope it's not encrypted and salted, or it's not a hash that we cannot get to. All right. Then we also have a username here. So let's go and get the username. And for this one, actually, I struggled a little bit to bring it together, because now you need to combine and make sure that you get this and this one here. Oh, Joseph said, you first need to define the number of columns available and return types to ensure that you are looking for. Oh yeah, that's actually good. I forgot about the number there. That's good. Thanks, Joseph. So now let's go and remove these. We know we need to select the username and the password columns, because that's where the information that we're after is. And to do that, we're going to keep using the union select command. Give me 1 second. But we need to combine these two. We need to make sure that we concact these two. There's multiple ways people do that. If you do a group concact, it will give you the information in the format that I like. But sometimes people just do the concact without the group by, and it seems to work. But we're saying, hey, union select. I would like these two here. So if you do a group concact, you can specify which tables you are interested in, and then you need to say from the table. This is exactly, if you have interacted with the MySQL or SQL databases directly, it's the same commands that you'll be running directly in there, but this time you're running from just the browser, but the commands will give you the same information. So we did the select of these two fields here, and the only special thing is the group concact. And if you are not familiar with that, I highly encourage you to spend some time reading the syntax, and it's really beneficial for you. And as you can see, you get all the noise again, but this time you get exactly what you wanted in the format that you specified. We specified with a semicolon here. A few weeks ago, we were able to, we chose something different. I think we put a dash or something in here as well. And it will group the results the way you wanted them to show up here. And in this case, it dumped a bunch of users and their passwords. So I'll copy these and paste them somewhere. Let me just add a section in these notes here for now. All right. So now we have users. So they're easier to see. So we have user John, Laura, Sam, and webmaster. What is the obvious thing that we can do now that we have usernames and passwords? We did not see a login page on this site, but going back to our Nmap results, which I already stopped, I think I cleared it. We had port 22. So there's a couple of things that you can do. You can start going through the list of these users. In this case, it's not bad, right? We only have a few users. Or you can make a word list of usernames and password and start brute forcing. But this time we actually have a username and a password name matched to each other. You can create two lists try to see if you can just run a simple script to brute force, or you can just sign in directly with one of these. So if you SSH as all these ones, they will all fail except for webmaster. So I'm going to sign in as webmaster because I know that one is the one that works. So most of the work was on SQL directly on the website. After this, everything is now smooth sailing at this point. Oh, by the way, before we go and sign in as this person, let's go and find out what does it look like when we're trying to do some detection on these things. All right, so I have a command that I already had here. And here's a nice takeaway for us. We were doing SQL injections in a browser. So if you're doing, say, threat hunting and you suspect that someone was testing SQL injections on your website, the part that I found in this insecurity onion is the http.uri keyword. This here will show us if we are looking for any keywords in the URL. So if we do an equals to, what are the things that people run when they are running SQL commands? I just put this will not fly in bigger environments. This will work for me because I have a very small database. But in big databases with millions and millions and billions of records, this might lock down your databases. But this time I can pull it off. Well, we know for sure in SQL, people run select commands. Like that. So this should bring me results where the select command was ran, and Zik is going to show me. So most of these here are instances where the select command was ran. Let's pick one of these. And as you can see, it's in the message. Let's move it up a little. Right here, it's in the message. So because nothing is encrypted, we can see things. You can actually track this down in the http.uri.keyword, and you can see instances where things were ran. Let's do a union, because I ran that so many times. Look how many times I've ran the command union, or at least the word union shows up in the URI. I know this because these are very specific to SQL commands. So let's see. And Zik keeps track of all the connections. And if you have any other things that keeps track of connections, you'll actually be able to see, oh, this one here is actually interesting as well. In the URI, that's exactly what we ran. So we can tell for sure if you are like, well, we think someone is trying some SQL injection on our website, and you have SSL decrypt, and you can decrypt the traffic, and you can see what's going on, you can go and track whatever commands they are running, putting your pieces together. So we know for sure that if we had done what we did here, we would have gotten caught. So if we didn't want to get caught, what could we have done? Maybe URL encoding, maybe something like that would have maybe helped us a little bit. If we had some time, I would try to send these using burp and encode these and see what happens. First, does it still work? And second, what kind of gibberish shows up in the intrusion detection system? And does this even fire any rules? Because right now, the defenders are going to create rules pretty much and say, hey, if you see this traffic here, or the word union, select, and all those in the URI, create a rule that says potential SQL injection is in progress, because they can do that. So that was part of our detection on that part. But let's SSH as webmaster, because we found usernames and password. It's 192.168.38.230. All right, then we paste the password. If it hangs like this, I think that shows me that it's working. Let me give it a second. Because we're just doing SSH right now, this is considered normal behavior, so I don't expect any anything to trigger unless if I fail so many times or if I had brute forced. Let me make sure that I copied the password correctly here. The username and password here. So Mecury is the size of 0.0568. That's the password for Webmaster. And that should let us in. As you can see here, I'm in as Mecury. Once you get into a machine, the first thing that you want to do is, of course, the obvious, like ID. I want to see what groups what kind of membership do I belong to? Am I a member of any funny groups like Docker containers or administrators or things like that? Sudo -L is another one, but I'm a part of the Webmaster group. And since I have a password, I might as well do a sudo -L. Can I run anything as sudo? I cannot run anything as sudo. It doesn't look like I'm any group, like the sudoers group or any interesting group here. So because of that, I will move on to manual enumeration. So the next thing is I will look for SUIDs and things like that, but I just want to read what's around here. So we have a user flag. I can do an ls-la. Select editor. Bash history. That's an interesting one. Because people can be very silly sometimes, so you want to make sure you check the bash history as well. This time it looks like it's being dumped, but you want to just do a cat bash history. Make sure that you don't have anything in there. Then, right now, I also noticed that I have a directory. That is not a standard Linux directory, so I'll go in there. This one is a database. It looks like, but I've already interacted with the database, so I don't think I'll be seeing any interesting things here. I have a manage.py. Who owns these files? Okay, I do. Here is a Python script for managing a Python environment. Okay. That's good to know. Then there's Mecury facts, index, and the same directory again. That's interesting. And notes.txt. All right, so I have to put a disclaimer here. This is just kind of like CTF kind of stuff. I find it mostly annoying that this happens in CTF. Machines that I make, you are almost guaranteed that you will not have user passwords laying around in notes. Sometimes people in the real world, people do these things, silly things like this, where they keep passwords in Excel spreadsheets and things like that. But this is a classic CTF, so we'll play along here. So for Webmaster stuff, we have a hash here, but we already have a Webmaster password. Looks like we have a Linux master. Is that a user? Yeah, that's a user. So we have a user called Linux master, and we have a base64. How do I know that this is base64? There's two equal signs here most of the time, almost not 100% every time, but you're almost guaranteed it's the base64 when you see those two equal signs there. So to make sure that they work, we can just do an echo, or you can use CyberChef here. Pipe it to base64, -D for decode. And now we have another password. It says Mecury. It looks like a password because there's something to do with the distance and things like that. This one, it's the size And this one is talking about the diameter. So that's the password for sure. So we're going to use that password to sign in as Linux master. So switch user. And we paste that password. So this is just some movement. Let me make sure that I have Linux master. Make sure that I don't have any spaces in my copy paste here. All right, so I'm in as Linux master. So this was just moving around as well. So I would do a cd. Linux master doesn't have anything in the home directory. Sudo -l. Can they run any sudo commands? This is the first thing, one of the first things that I do. And here I'm looking at, don't ignore this right here, but sometimes you do find interesting things that you can actually exploit. Don't just rush to the last one. So two things that stands out right away. We can run as root and we can run whatever this thing is. But there's this value here, set environment. So there is an environment that's set to be able to run this as root. Well, first, let's see, can we modify that file? All right. Looking at our permissions here, doesn't look like we can, but that's okay, because we need to read it. What I'm going for here is I'm looking, are we running any Linux commands within this script? And if we are, whatever we are running, in this time we're running tail. That's interesting. If you see a script that's running as root that you can run and it's running any Linux commands that you, or binaries that you can find in the binary or the user bin, you can start digging around and make sure that things work. So let's go to GTFO bins. And that's tail. So when you go to GTFO bins, you see that we can actually mess with tail by linking some files here using this method here, where you can say, here's the file to load. You want to trick the system. Here's the idea behind this, so that it's easy. Since this is calling tail, and these binaries are shared by everybody, right? Tail that I run as Linux master is going to be the same tail that root is going to run. So if I can trick the system to run tail that is located somewhere, tail that I can control, and a tail that is in the path earlier than the real tail. So this is like, I create my own tail. I tell the system, hey, here is the path. By path, I mean this path right here. If you're not familiar with the path, you need to go and educate yourself in exactly how this path works. But in a nutshell, when you say, hey, Linux, run the command tail, Linux is going to start looking here. See, is there tail there? No. Then you move on to this directory. Is there tail? No. And so forth. So what you can do is you can create your own tail, put it earlier than the actual tail, and it will just execute that. It's kind of silly that way. So because this is running as root, this tail here is going to be our way in, because we're just going to trick the system and say, hey, by the way, system, run this tail, and then we'll execute the script. The script is so dumb, it will just run our own tail. So I know I tried to explain it. I hope you get it. If anybody has any resources about what I'm saying here, please post here. This is not the first time we've done it here on these live streams. We have actually abused the path. Actually, I have a video that I think on the thumbnail it says abusing path for privilege escalation. That's the same idea. So instead of creating a binary that we know is going to work, or a script and calling it tail or anything like that, let's leave off the land, right? Let's use something that we know would spawn a shell anytime. And Vim is one of those things that will spawn a shell almost every time. If we go back to GTL4 beans here, it will tell you how Vim or VI can be used. Okay, let's go back to the main. Maybe I'll do Vim, because Vim is better. And for Vim, let me just click on one of them. You can spawn a shell with Vim by doing this, by putting this inside of Vim. So what we're going to do is we're going to tell our system, hey, when someone calls for tail, run Vim. And then once it runs Vim, we'll spawn a root shell using this method here. So let's do that right now. To do that, we can just say, first, let's locate Vim. I think VI lives in bin. What am I doing? Let's cat cd / bin. I'm just going to do things by hand here. Okay, so it looks like in here we just have VI. So Vim lives somewhere else on this system. It must be in the user directory. cd / user bin. I think this is where it is. So now you know VI lives in one place, Vim lives here. Actually, we have both in here. That's interesting. That is very interesting. So we have binaries for VI in both user and in the search bin. Okay, so we're going to use bin, Vim here. To do that, we're going to link S / user bin Vim. We want to tell the system, hey, by the way, link that to tail. Exactly. First, we link that to tail. Then we need to set our path and say, hey, by the way, our path is going to start from here. And to set our path, we type the export command. We want to set the path to be, let's just do a print working directory. I'll do a $pwd, meaning where we are right now. And we would also want that to be tagged to $path. So I'll show you now what the new path will look like by doing an echo for the path. We're saying, okay, let's now set we linked first to tail. So that means that when we run the command tail, it's going to look for Vim. Then we tell it, hey, this is the new path here, and I'll show you. Of course, I need to say export path equals to. This is the easiest way to get root. Now let's echo our path and see what it looks like. Look, now it's starting from here. That is a good thing. We need to make sure that it's linked because it's starting from here because we linked it in our profile here. All right, now that we know this is happening, next we just need to make sure that we execute the binary that has the command export. And when that executes, it will execute and pop up Vim. And Vim, we can escape and get a shell from it. And when we get a shell, we get a shell as the user who executed Vim. And the user who executed Vim in this case is going to be the one who actually ran the command, which is root. All right. So now that we did that, let's do a quick recap. Sudo -l, then we can run the command here in a second. Because we have this set environment here, we need to make sure that we preserve that environment. We cannot just run this right now. It will not work. It needs to be within its own environment. That set environment is relevant. So because of that, I'm just going to run the command sudo. Then I'll do a dash dash. I think it's preserve. I had to look this one up as well. Let me just show you the full command here. We need to make sure that we preserve that environment, otherwise it will not work. I spent some time there stuck thinking, I did everything right. What's wrong with this? Then I came back and I looked at this, and I think someone with Stack Overflow said something about this one. So sudo, make sure to preserve the environment equals to path that we already had. Then run the script. And what's going to happen when you run the script? It's going to execute tail, and tail in this case is going to bring us Vim, which is what we wanted to. And now that we have Vim, which is exactly what we have here, according to GTFO bins, Vim, we can just escape using the escape : this right here, bin sh or bin bash. So I'm going to do an escape : then you can do, what was that? Exclamation mark. I'm having a such bin bash. It was bin sh, but bin bash should also work. If I hit enter here, I should get a shell. Maybe I should have gone for bin bash, because now I have to fix this shell. Where am I? I'm now root. So you just learned how to do privilege escalation by setting the path. I think there's a good name for it. And just, if you find a script that is running as root and it's running any Linux commands, consider this way your way in. And there we go. So a lot of credit goes to this creator here, SafeFlash. You can find him on VownHub, and you can also email him here. It's really great. I found this machine to be very, very helpful in sharpening our skills, especially for practicing ethical hacking. So if you really like this stuff, please make sure to subscribe and like. Make sure to help me get to, I think I can get to 20, where are we? 27,000 subscribers. Maybe next year we can get to 30,000 subscribers by end of March. So please subscribe and like this video and invite your friends as well. While we are done with that, let's go back and see what else can we see from the attack that we did. We did not spawn any shell today, so there's no ports for us to track down. But what if we can just do, let's see, how many times did someone interact with port, say, 22? This is a big stretch because I only have one machine that has port 22 in this environment. If you have a network with a lot of Linux machines, your results will be way different. So let's do a destination port of 22. I'm just curious, how many times did we get there? Not many times. 27 times here. This probably was some probing from Nikto. And these 2 times here are probably me failing to get in. Like you saw me failing. And the interesting thing is both of them are ZK-con events. So Zik is what found this. So you can use this to validate your assumptions. If you think, well, did this attacker really SSH after finding the passwords from the database? You can come in here and see, oh, destination is a victim and the source was the attacker. The same source that was doing SQL injections now also visited your port 22 at this time here. So now you can start putting 2 and 2 together. Say, we actually really got in trouble here. Unfortunately, we can't tell what happened because Surikata didn't catch it. Surikata is really good at telling us like a better story. But in this case, this is what happened on port 22. Let's see Nikto. What happened with Nikto, the 2 that we ran? It's very important that in as much as you want to be an attacker, you want to enjoy the attacking and it's so much fun, you really need to know what noise you generate. What does that do to a client environment? What does that do to a victim environment? If you run a script, what alerts is it going to trigger? It would be very, very silly of you to go in someone's network and just start going at it without thinking about ways that they can catch you or ways that you can trigger intrusion detection systems like this. So it looks like we only have a bunch of Nmap and Nikto here, which is just, we didn't generate a lot of noise today. Let's do a drill down. Okay, this was destination port 22. That was probably Nmap probing port 22 for any kind of information. That's how we probably got the version information here from this rule. So if you wanted, you can go and read the rule, which is also a very, very important skill. Try to understand, okay, this is a Surikata rule. How are these rules constructed? Try to see, okay, if this rule fired, which part of what I did today might have triggered this rule. And that's also very important for us in this case. So this time it looks like it's looking for a flag. Is this an Nmap flag of a scene flag? If anybody knows what this flag here is, please let me know. I'm not too familiar with this. I'm actually going to try to understand what flag was that. Is that a scene flag? It's part of the TCP handshake. Anyway, that's what I had for today. If you haven't joined, please, let's do the Try Hack Me Advent of the Cyber. Tomorrow is going to be day 6. I plan on doing all 25. And they're very, very easy, but you will learn a lot. If you are just beginning, a lot of people keep asking, hey, how do I get started? Advent of the Cyber is a perfect way to get started. You get taught everything from the beginning, from scratch. And make sure to join me on this channel every single day. I will make sure to share with you after I've completed the room. It takes me literally like 20 minutes between doing the room and recording a video. Sometimes I just record a video as I'm doing it. Then I edit most of my mistakes afterwards. So please make sure to follow along with me. If you have any questions, please let me know right now. Otherwise, my next plan, since the OSCP has changed and they're talking about Active Directory, I will be making Active Directory machines, and I'll plan on, at the beginning of the year, continuing to build our Active Directory lab. So not only do we get to pen test Active Directory, but we actually interact with Active Directory. I have 11 videos that show you how I have set up the lab with the Active Directory before. And I'm very excited that they moved the OSCP to Active Directory because that would have been fun when I took it. But if you're going for the OSCP, I think you're going to have a lot of fun with Active Directory. Your life is probably going to be easier. And here's why I say so. There's so many things. I mean, you can count at least maybe 5 or 8 common Active Directory attacks. So no matter what they're trying to do with you there, you're going to be around the same things, the same ways of attacking Active Directory. So I think the OSCP just got easier than worse, because before you didn't even know what you were going to see. This time you know it's going to be an AD environment. I need to make sure that I interrogate Active Directory, and the material is really good. I learned a lot about Active Directory going through the PWK videos. So that was interesting. And thanks everybody for joining. I really appreciate it. I saw a lot of people were here today. Someone must have shared my live streams. I saw people come in and go. But without wasting a lot of time, thanks for being here. I will see you for sure tomorrow. In the morning, I'll be posting another video. And next week, we'll be here attacking yet another machine and learning. So thanks for being here, and I'll see you later.